my this call. I'm going to present you kind of specific technology that we are developing at Luos, and I'm working on from more than 10 years now, and allowing to develop software for distributed electronics, for distributed architectures, on how to deal with those kind of complex hardware configurations. So I'm gonna explain you why we are doing it at Luos, on how we are doing it, and after that I'm going to show you how Luos is working into a small demonstration. And at the end of this call, you will be able to ask me questions through the Slack on track 1. So let's start this call. So first observation, embedded developers are like old school languages and technologies. That's probably because we are working on really high constraint environments, and whole technologies also worked on highly constrained, on limited environments. So those kind of technologies still be really useful for us, and because hardware is really slow to change and to make evolve. So that's probably why software, high-level software, have evolved a lot and use a lot of new concepts on new language and a lot of different technologies that not so many people use on the embedded world. So the problem with that is that the way we develop systems never really evolve, and we're still developing our system in a really monolithic way. I mean, when we develop a software, we make this software for one specific project on one specific hardware, which is extremely difficult because we can't easily reuse the work we are doing on one project. And it's really also difficult to make it evolve and to pass the work to make someone else work on a project we are working on. So a second observation, embedded world go to a lot more distributed every time. So there is a lot of different market with where embedded is always distributed, for example, like planes, car, robots, and stuff like that. And even computers are distributed machines because there is a lot of different microcontrollers in like the hard drive and all the different components allowing your main processor to run smoothly without having to take care about how to access the data into this specific hard drive or something like that. And even on the microcontroller itself, now we have microcontrollers with multiple core in it. For example, like microcontrollers with allowing you to do like Wi-Fi. There is a core for the Wi-Fi and another one for the user code. So distributed is really good for a lot of different things because it's allowed to, as I mentioned here, this distributed environment is due to growing sophistication. So we can have a really more complex machine using this kind of architectures. And we can have some specific power efficiency strategy in this kind of things also. Performance, of course, security, and for mechanical constraints, for example, in robotics, when you need to have like complex motor control close to the motor, and we have a lot of motors everywhere on the robot, you need to have mechanically the board close to the motor. And for modularity, of course. So there is a lot of different reasons why people use this kind of architectures. So this distributed things means a lot of complexity because you will have to deal with communication between boards, between microcontrollers, time synchronization, resource sharing, determinism. You have to manage collision and priority. And there is a big work just to start having something able to develop the behavior of your machine. And it's extremely complex. So how to solve it? In the software industry, they find a solution. They call it microservices. I don't know if you all know what is microservices, but basically microservices is a way of thinking a development. And when you develop a software, you just think it like small bricks, small independent bricks, allowing to do some small features, and you just make all those bricks communicate together to have the complete application you want to have. And it's a lot used on the web world, for example, on like a chatbot or payment system. Today, no one going to develop a new custom a chatbot, for example, for his website. People just use available solution by other people just making like a chatbot. And those kind of services can run on different servers. And you don't care about where this service is, you just can reach it and communicate with it. And this kind of way of developing, the microservices way, have been pushed by some technologies such as Docker or Kubernetes, allowing to simplify the way developers manage those kind of small services. And we think at Luos that this kind of thinking about the way we develop applications is something missing on the embedded world. So that's why we have created Luos. At Luos, we are working on an open source on real-time orchestrator for distributed architectures following a microservices philosophy. So the idea is just to allow developers to create small services and to declare them between all the boards of a system. And any services of any boards of this system can just use it as if all those services are on the same component. So you don't have to think about where it is on how can I access to this specific data into this specific board. Just Luos just allow you to do it directly. So there is different companies already working this way. We think they develop their own technologies, allowing them to think their product and to design their product this way. And this way of thinking also allow developers to follow CICD methodology to test and improve product development. CI means continuous integration, and CD continuous deployment. And this is a methodology used in the web world to continuously improve a website without having to stop it, to update it. And they can just make it evolve continuously by getting feedback from their user, improve the code, test it, and deploy it directly online. And this microservices way allow product developers, electronic product developers, to do the same. So now I'm going to show you a small demonstration on how Luos is working. And I'm going to go a little bit deeper on this. So here I'm going to show you my face now. So I'm going to show you how to make a small bike alarm, connected bike alarm, using Luos. And I'm going to make a small distributed architectures, allowing me to just demonstrate how it's working. So to make it work, I'm going to use this kind of boards here. This is specific boards we made at Luos, but we don't sell it or anything. This is just for a demonstration purpose. And of course, Luos work on any kind of hardware, and our solution is made for people that develop their own software on their own boards. So of course, when you are developing a product, you have your own boards, and you can just use Luos as a library into your code. But for this example, I'm going to use this board. On this board, I have 2 connectors here, allowing me to just chain a lot of those kind of boards. On top of it, I have different kind of shields, allowing me to have different sensors and effectors into my system. So on this board, I have a shield with a motion sensor on it. And the idea is to make a bike alarm. So the idea is to, when the bike is moving, I want to have a LED, RGB LED blinking, which is like a really simple alarm. So in this board with the motion sensor, I put one service, which is a driver service. We make a difference between a driver and an application service, because it's really important to separate service linked to the hardware and software that want to make the behavior of your machine. It's important because if you change the hardware, you don't have to change anything into the behavior. You only have to change something on the hardware side, on the driver side. So it's really important to separate drivers and behaviors on application services. So in this one, one service, which is a driver one, allowing me to access to the motion sensor. So this service just will be declared into the system, and anyone can just use this sensor. On this board, which is an RGB LED, I put 2 services. One, drivers allowing me to access to this RGB LED, and another one, which is an application one, allowing to get the value of this service here and to make the LED blink when there is a movement. So to make it work, I just connect those 2 boards together, and I'm going to use a power plug to emulate like the battery of the bike. So, yeah. So, as you can see, now the LED is blinking. So if I succeed to stop moving, as you can see, the LED just blink and stop. And if I move, the LED start blinking. So basically, it's just a simple alarm. And what's happening when I plug the power in? The application on the LED here makes something we call a detection. So this detection allows Luos to detect the physical position of each board into the network. And based on the position of all the boards, we distribute a unique ID to all the services onto the network, and we regroup all those information into a structure we call a routing table. And we share this routing table to all the boards on the system. So now all the boards know all the services available into the entire system and just can use it directly. So I don't mention it, but in this case, we are using the power element, we are passing, the power on the network into this wire, which in this case is RS485, but Luos can deal with a lot of different communication ways. This is just, Luos is just a technology to send messages between processes, and that can send those messages through a network. So we can use any kind of network into your device. So there is now we have a really simple alarm, but we can't really use it on the bike because we can't start or stop it. So we can't control it. So to make it work for a bike, we need to add something. To add this capability, I'm going to add a new board on it, on my system, which is, as you can see, a push button. On this board, I put 2 services, one drivers allowing me to access to this button, and another one, which is an application one, monitoring continuously the state of this button, that have for purpose to just start or stop this alarm here. So I can just add these small boards into my system. In this specific case, we can deal with hot plug. Luos never make dynamic detection by itself. So this is your work as developers to just choose when Luos run a detection. In this specific case, when I add this board here, if after something like 30 milliseconds, no one detect this board will make its own detection. So after this new detection, all the boards on the system just know that there is a new board with this and this service on this service and just can use it. So as you can see, the alarm still running. And now when I push this button, as you can see, the LED turn white and the alarm just stop. And if I want to turn it back, I just can push it again. So now we have like a simple behavior, but splitted into multiple small software distributed into different boards. We have a piece of software here, a piece of software here, and those two software use concurrently different kind of resources into different boards easily. So you can continue to develop your entire system following this strategy. And in this specific setup here, which is like a proof of concept, now that we have something working, we can just rethink the hardware and, for example, merge all those boards into only one board, and you still have exactly the same software on it. You will have to change a little bit the drivers because you will have to change, for example, the pins for the LED or something like that. But the behavior of your system still exactly the same. You don't have to change anything because the API of all the services is still the same. And at Luos, we define some basic types for services. For example, we have a type for distance sensor, motors, or angular sensors. And also, Luos is able to just translate the value on the fly. For example, if you have an angular sensor working in radian and you have an application working in degree, both of those applications can just choose the value as they want, and you're just going to translate it for what they need to have on the value, on the matrix of this specific angle. Yeah. So now I'm going to show you how to use this kind of embedded system directly into like a cloud platform, because what we are doing is a connected bike. So to make it, I'm going to add this one, which have a USB shield on it. On this board, I put a specific service we call a gate, which is one on the only service we are maintaining at Luos right now. And this service, this specific service, just translates everything happening into the Luos side into a JSON format, and you can just stream this JSON into any way you want. So in this specific case, I'm going to use USB, but you can use Wi-Fi or Bluetooth or anything you want. So to make it work, I'm going to add this new board into my system, and I'm going to unplug my power because I'm going to switch into USB power. It will be easier for me. Okay. And I'm going to show you how to control all this bike here we made directly into Python. So let me share my screen again. Okay, so here is a small piece of software, a Python software, and we are using a lib called PyLuos. This library don't do a lot of stuff. It's just allowing to simplify the connection through to these small boards here. So the interesting line is this one. In this line, we are connecting this Python program into the USB ports. I'm going to check if my USB is the good one. Yes, and it's going to create a bike object. In this bike object, I'm going to find all the services I have onto my embedded side. So if I run this piece of code here, as you can see, we can just show on the bike object. And here is a graphical representation of the routing table I mentioned previously. As you can see all the boards, and you can see how those boards are connected together. In this specific example, it's really simple because all the boards are connected into series, but we also be able to make star connections. And you can see all the services available onto all the boards. And you can just use those objects here as variables and to take control of any features of your embedded side. So for example, here I'm just display a small 3D bike, and I link this 3D bike to my motion sensor. So when I move here, you can see me moving, I think, but as you can see, the bike is following the sensor measurements. And on the embedded side, the code still running. So I still have the alarm and everything working fine into the embedded side. So you just can get the value of the sensor like that. And you can do it the other way, natively. So for example, if I want to start or stop the alarm, I can make it through this Python code here. So here is my bike object. I want to access to the start control service, which is in this setup, the service monitoring the push button on start or stop to switch the state of this alarm to false. And I can show you because you can see my camera at the same time, but when I just execute this line, this is exactly the same thing that if someone just push on the button. And if I want to turn the alarm back, I can push on the button or execute this line in the other way. So, and the other interesting things here is that you don't need to develop anything specific into the embedded side, allowing you to just take the entire controller of your device into a Python language or any other language you want to deal with. It's just like a native things Luos can do. And it's really allow people to do the link between the software world and the cloud world, for example, on the embedded side, without having to develop a lot of things to make it work together. So that's it for the demonstration. I don't know what I'm missing about our technology. Yeah, I don't mention how technology can work. So we can, most of our users just use Luos as a bare metal library. And we also can work on RTOS, for example, without any difference. Basically, Luos is just a library allowing you to just declare some services and use services and find services into your machine. And yeah, also because we standardize the services, the API of the services. Applications can work on any Luos machines. So, for example, here the alarm I just show you can work on any Luos machine. So, if I just copy paste the software of this alarm into a robot running on Luos, this program will just find a way to make it work. So we're going to find the sensors, and when the sensors is moving, you're going to find something like a LED or something to make sound or something like that, just to notify the user that there is something happening into the device. So you can make applications running on any kind of machine directly on bare metal or into RTOS. So that's it for the demo. I don't know if you have any questions about all of this. And you can ask questions through the chat, because as I just see right now, the chat seems to work, or into Slack, into track 1. So Christopher have questions. What languages can the service be written in? Okay, so when we are in the embedded world, we only have C for now. At the beginning, the Luos library was written into Rust, but embedded developers are not ready for Rust right now. So we have a lot of customers fearing about it. So we just go back to the good old C. And yeah, the library is written in C. And but of course you can use it on any kind of languages you want, just by binding the C API to any kind of language you want. And what interface I supported for communication between boards? Basically, we support any high duplex communication way, like really low-level communication, such as, for example, simple UARTs. And in this specific case, Luos just monitors everything on the hardware side into the network. So you can manage how to deal with collisions of message, because we don't need any master here. So it's massively multi-master. So we need to deal with collision on priority between messages. And we have to have a specific way to drive the network to be able to do it in low-level interface. And we also can use higher level interface. So for example, like EtherCAT or CAN, which are a communication way that have a protocol on top of it. And in this case, we just encapsulate how our data format directly into the payload of the communication way. So basically, we can use any kind of communication way, and the communication way we use is completely multicast. So when we send something, everyone just receive it. We don't do daisy chain thing, and so we can reduce the latency a lot by using it this way. So as Christophe mentioned, you can it's preferable to use the Slack channel track 1 if you want to ask questions, because the chat is not always working. So I don't know if you have any more questions. If you have, you can still reach me on the Slack, and I will be available a little bit into Slack. So do not hesitate to ask me. So a new question from Christopher, which is, how many boards can you connect at once? It's depending on what you are using to communicate, because the limitation here is the impedance your physical bus can support. So basically, for example, depending on the driver for RS-Wi-Fi you are using, you can plug from something like 30 boards into the network, but it's depending on the physical specification of your bus. And in the Luos side, we don't really have any limitation, because it's just the number of address we can have. And for now, we have 12 bits for addressing all the boards. So yeah, you can put a lot of boards virtually into Luos. This is just depending on the hardware. Okay, so if there is other question, please let me know through. You can just reach me directly into Slack. And thank you for connecting you in this talk today. And I hope to see you soon. And please reach me if you have any questions on you want, or you need any more information. Thank you all. Have a good day. Bye.